Historically, it seems like most of the research community has been focused on throughput rather than accuracy. So why is that?
The cost of sequencing has rapidly come down, really driven by throughput increases over the last several years. But what we're seeing happening is a range of new applications and a larger number of samples being studied now. And so the relevance now shifts to the quality of the studies that you're doing and the accuracy and quality of the data you're generating for those samples, so we can wrap it into a biological context with high confidence.
Throughput versus accuracy is very important, but equally important, I think, is the concept of throughput versus efficiency, right? Because you have a high throughput system, but it doesn't result in a lot of usable data, then really the cost of your sequencing actually goes up per experiment.
And I think the fact that the cost is going down is starting to enable the first wave of reasonable-sized cohort studies on sequencing platforms. And I think that's forcing people to reconsider what's valuable in terms of looking at your false negative rate across a cohort compared to adding more samples. And so there's a whole reevaluation of, do I want more samples, do I want more reads, and do I want better reads? And that's one thing we looked at in the study.
I think there's still a lot to be done on families, single pairs. I think there's still a lot there happening, and it's very exciting. But you're right. We're also seeing people starting to throw a cohort at whole genome and say, this is a bigger problem. I need more information. Let's go at it. And that's really exciting. But you're right also, accuracy there is going to be tremendous. So you're going to invest in quite a big study. Do you want to spend your time checking your data, or do you want to spend your time looking at what you're looking for and moving on to the next step? And I think that's really what accuracy buys you, is to move from the technology, the samples, to really the answer you're looking for, and not to have to sort of play around with the other stuff. And so I think we'll get there.
And I think you're talking about the human factor, right? And the human factor comes when you start to scale up. And that's, are you more concerned about whether any one run was a success, or you're to a point, because you understand the accuracy of the system, that you can trust measurements on a scale, in a high-scale fashion?
Absolutely. And so the ability to look at your whole system as it comes through genome by genome by genome, this is what you care about at this point.
Sort of saying that there's a hidden cost without having accuracy. There's a hidden cost that's unfactored within the whole system if the accuracy isn't sort of at an acceptable threshold.
Definitely. This is all about information, which is not about data, it's about information. If you have a lot of data with little information or hard to reach information, you have to just gather a lot of it. If it's information rich because it's accurate, then you don't need as much. And this is where the cost comes. It's really the cost of data to the value of the information.
And then I think the better you understand the accuracy and what's contributing to it, the higher your trust. And the higher you trust the data, and the more you trust the data, the more you can go on and do more ambitious experiments.
And when we look at whole genome data completeness, it's really important. So things that we highlight there is sort of the evenness of coverage, the gap size, the number of gaps. These things really matter. You'll find them at the end in other metrics like false positive rate. So they really are significant, and I think we do a really good job at it.